Good afternoon to all of you. We are going to see a spring mass system where there is a spring, a light spring, it has negligible mass, connected to two masses M1 and M2 lying on a smooth horizontal floor. What we are interested in is, if we disturb the system by pulling M1 and M2 apart or pushing them in and leaving it, the system will oscillate, and we are interested in what will be the time period of this system. Now, before we go to that, let us see what is the defining equation of a simple harmonic oscillator. Defining equation is A is equals minus omega squared x, where x is the displacement of the particle from the mean or equilibrium position. A is the acceleration. It is the double derivative of the displacement, d2x by dt squared. dx by dt is v and dv by dt is a. So therefore a is d2x by dt squared. Omega is the angular frequency in radians per second. And omega is 2 pi by t. T is the time period of the oscillation. That is the time taken for one oscillation. Now, let us take a simple system whereby you have a spring fixed to a wall and there is a mass m on a smooth floor like that. Yes? Now, this will be the equilibrium position because the spring is undistorted, so there is no spring force. The floor is smooth, there is no friction. So the net force on the mass m is 0. Therefore, this is the equilibrium position. Now, supposing we pull this mass by a distance x and release it. Now, when you pull it to the right, there will be a spring force kx acting on it to the left. Now, we could write the force equation. We know F net is equal to m into a. Now the forces and the acceleration are all one-dimensional vectors. They are along a straight line, along this straight line. So there are only two directions possible. One we can call it as plus, other as minus. So F net we will say is minus kx because we are choosing the direction of x as positive. So this is opposite to x, so minus kx. That is equal to ma. So therefore you will have a is equal to minus k by m into x. If you compare this with the defining equation of SHM, this is omega squared. So omega would be root of k by m. That is equal to 2 pi by t. That gives us t equals 2 pi root of m by k. Yes, this is the spring mass system in its simplest way. Now, let us go to this system where you have two masses. Let us pull them apart and by a distance, let us elongate the spring by x. So, we are pulling this apart. This was the equilibrium position. So this we are calling it as x1. This is mass m1. This is mass m2. This we are calling it as x2. We are going to extend it like that and leave it. So the total extension of the spring x is x1 plus x2. Yes. So the spring force on this mass m1 would be kx in this direction. On m2 it would be kx in this direction. Now we notice if you take the spring and the masses as one system, the net force is 0. Because the net force is 0, the center of mass of the system will not accelerate. Now since the spring mass system was initially at rest, so the center of mass was at rest and since it will not accelerate, it will continue to remain at rest. So where is the center of mass? So let's say this is the center of mass. It will not move. The center of mass will remain as it is, and let this distance be L2. Let this distance be L1. Yes. Now let us choose the center of mass as the origin. So the original position of M2 would be, original coordinate of M2 would be plus L2. Original coordinate of M1 would be minus L1. After you pull it apart, the coordinate of M2 would be L2 plus X2 and the coordinate of M1 will be minus L1 plus X1. Yes. So let us see. We can now write M2 into L2 plus M1 into L minus L1 for the initial position by M1 plus M2. This is the coordinate of the center of mass by the basic definition. Now, since the center of mass is at the origin, this would be equal to 0. Therefore, if you simplify this, you will get M1 L1 is equal to M2 L2. This is one equation. Now, for the extended position, you can do the same thing. It would be M2 into L2 plus X2 plus M1 into minus 1 into X1 plus L1 by M1 plus M2, that is equal to 0. So you are going to have M2 L2 plus M2 X2 is equal to, we'll take this to the other side. M1 plus M2 will multiply with 0, it will be 0 there on the right hand side. If we transfer it here, you will get M1 X1 plus M1 L1. We already saw M1 L1 is M2 L2. So we can cancel this and therefore we get M2 X2 is equal to M1 X1. Yeah. Now we will write the force equation for M2. We can write it for M1 also. Both are going to yield the same result. So first let us write the force equation for M2. So I will say F net is equal to M2 into A2. Now again it's a one-dimensional vector. So F net I can say is minus Kx into M2 into A2. Now you see, we cannot directly compare this to the defining equation of SHM. Why? Because A2 is d2 x2 dt squared, whereas you have an x here. So we would like to eliminate this x2, this x from here, and replace it by x2. So we know x is x1 plus x2. So we can write this as x1 plus x2 is equal to M2A2. We will eliminate x1 by using this equation. I will call this equation 2. x1 is M2x2 by M1. So I can write it as M2x2 by M1 plus x2 is equal to M2A2. So x2 is common. I will take that out. So I get minus k M2 by M1 plus 1 x2 is equal to M2A2. So if I simplify this, I will get k M2 plus M1 by M1. I can get this M2 in the denominator here into x2 equal to A2. Now I can compare this to the defining equation of SHM. So A is equal to minus, this whole thing here is omega squared. So that will give me omega is equal to root of k into M2 plus M1 by m1, m2. Now if you see this quantity m2 plus m1 by m1 plus m2 has got dimensions of 1 by mass, because you have mass, dimension of mass in the numerator, and you have the dimension of mass squared in the denominator. So we will say put this as 1 by m as m2 plus m1 by m1 m2. So this will be square root of k by m. Yes, where m is given by m1 m2 by m1 plus m2. So the time period can be easily got from this. Omega is 2 pi by t. Omega would be 2 pi by t. So let's write that. Omega is 2 pi by t. So this will mean t will be equals 2 pi root of, if you is root of this is equal to root k by m. So that gives us t is equal to 2 pi root of m by k, where m is m1 m2 by m1 plus m2. If you apply the force equation to m1, that is, if you had written f net is equal to m1 a1 and eliminated x2 and got a1 in terms of x1, the final result would be exactly the same. That means both the masses will oscillate at the same time period. Okay, will have the same time period of oscillation. In fact, when both will be at the extremes, both will be at the mean position, both will be at the other extreme together. So the time period is going to be the same. Now this mass is called as reduced mass. This mass is called as the reduced mass. Why do we call this the reduced mass? See, we have 1 by m is equal to m1 plus m2 by m1 m2. So this can be written as, if I divide this denominator to each of the components of the numerator, I will get 1 by m2 plus 1 by m1. So 1 by m is 1 by m2 plus 1 by m1. Now since 1 by m is this, I can say 1 by m would be greater than 1 by m2. Yes, because this 1 by m1 is a positive quantity. If I remove that, this quantity will be lesser than 1 by m. This implies m will be less than m2. If I take the reciprocals, similarly I can say 1 by m is greater than 1 by m1. This implies that m will be less than m1 also. So m is less than m1 and less than m2 also. Hence it is called as the reduced mass. There is another approach which you can take to derive this. Before that, let us see how the system of two masses m1 and m2 connected by a spring is equivalent to a single mass connected to the same spring constant, single mass m connected to the spring constant, where m is m1 m2 by m1 plus m2. That is, you have a spring mass system with spring connected to the wall and the mass equal to the reduced mass of the system. There is another approach you can take to do this problem. See, this is an Oscillator we are giving you an alternate method. Supposing you have the spring mass system M1 and M2. Well, we said that the center of mass doesn't move. The center of mass is at rest. So let's say the center of mass is somewhere here. Since it doesn't move, I could create a wall there. And I have one spring mass system here and another spring mass system here independent of each other. So, if this can have a spring constant K1, this can have a spring constant K2. Let us say this length of the spring is L1 and this length of the spring is L2. Now, we have seen in our video number 8 on springs, cut springs, series springs, springs in series, springs in parallel, that the spring constant K is inversely proportional to the length. So, here I can therefore say K into L is a constant. The spring constant to length is a constant. Therefore, I can say K1 into L1 is equal to K2 into L2 is equal to K into L, where L is the total length. L is nothing but L1 plus L2. This we are talking about is the unextended length, the undistorted length of the spring. L1 and L2 are also undistorted lengths of the two springs. Now, we also know that because L1 and L2 are measured from the center of mass, we can say M1 into L1 equal to M2 into L2. So here if you see the time period of this system, T is equal to 2 pi root of M1 by K1. Our object is to get K1 in terms of K, because that is what is given in the problem, in the system. So how can we get K1 in terms of K? Use this. K1 is equal to K into L by L1. So that will be K into L1 plus L2 by L1. So what will that reduce to? We will have K is equal, K1 equals K into 1 plus L2 by L1. Now this is K into 1 plus, I know M1 L1 is equal to M2 L2. So L2 by L1 is M1 by M2. L2 by L1 is M1 by M2. So this would be K into M2 plus M1 by M2. So what is the time period now? T would be 2 pi root of M1 by K1. We saw that. So we substitute for this. It will be K M2 plus M1 by M2. That will be 2 pi root of M1 M2 by K into M1 plus M2. That is M1 M2 by M1 plus M2 is the reduced mass. We get the same result, M by K. In fact, if you wrote for the other one, for the other spring, it will be T equals 2 pi root of M2 by K2. T equals 2 pi root of M2 by K2. If you substitute for K2 instead of K1, you did all these manipulations as we did for K1, you would get the same result. Thank you.